Hello everyone, I'm Wang from TetraScience. So today in the next 20 minutes, I'm going to walk you through the journey we took to design and create the TetraScience file converter. Our goal is to package the heterogeneous experiment data sets into one single file, leveraging the Allotrope ontology and HDF5. As you can see throughout the entire presentation, our goal is to optimize this for data science and cloud computing use cases. So to level set ADF, it is built on HDF5. It has the data description for the semantic data model, summary data, metadata. It has the data cube for the multidimensional numerical matrix. It has data packages, a virtual file system that you can put kind of whatever files inside of that. So the goal is to package almost everything that you can package into a single file that you want to know about the experiment, the raw data, the results, the context, and on top of this, the foundation provides a semantic web data model using RDF. So to level set, this is our understanding, and this is kind of the community's understanding of ADF. Let's simplify that. ADF is truly a combination of HDF5 plus a semantic web RDF. Right, those are the core pillars of the technology of the framework. And if you think about the semantic web RDF, it has the Allotrope foundation ontology, defines what is an injection, the IRI, and also the data model. How do you put together those IRIs together into a graph, such that to capture the relationships. Okay. So I want to give you some provide a updated summary of our observations. Again, every Allotrope Connect workshop will present and provide our most updated understanding of our experience in this community. So we are noticing that the scientists, if you talk to the scientists, they care much more about the use cases. How do I see my data in a particular diagram, in a particular way, providing the type of analysis that I want, much less about how the data is organized beneath the visualization or the analysis, right? They don't really know, they don't care. A lot of them don't. Enabling data scientists has become a high priority for a lot of the organizations, including a lot of the folks in this meeting. The life science R&D labs have heterogeneous data sources we call producers, since are producing the data, like different kind of instruments, different make and models. For example, just one vendor's mass spec data can look all different depending on the method it is used, or depending on the LC, on which vendor provided the LC module versus the mass detector. So very heterogeneous. And also you have a lot of systems consuming the data, ELN, LIMS, sample registration, visualization, and coupled with item number 2, more and more data science applications. We also want to provide updated observation on the Allotrope file format. It is an evolving standard. Things are changing, right? Last month, the aggregation pattern was finalized, and new models and new patterns are being discussed and released. And the library is also evolving based on the feedback. We also observed that semantic web has the RDF, has the overhead, is non-trivial to work with. Our observation is that very few scientists and data scientists actually know semantic web RDF. The reason we are saying this is because we have a lot of trouble in the hiring process. We're not able to find scientists and data scientists who are good at their job and also understand semantic web. This has been a very difficult hiring challenge for TetraScience. And also we still have the chicken egg problem. Member companies want vendors to adopt. Vendor companies want more documentation, more mature ecosystem, and then take that on. So there is a little deadlock over there. Let me show you our experience. So we did the following. We spent a lot of time, months and quarters, put our best engineers to develop put the data into the RDF graphs. We have to handcraft this because the graph is just complicated. I mean, there are patterns that we can automate, but I mean, you can see all those lines connecting the dots. It's all handcrafted. It's not trivial. And we then realized and heard that even some of the most complicated and sophisticated graphs don't really have enough information. This is verbatim hearing from the people we're trying to serve the product to. And it does not cover all the terms that scientists need. We also heard that Spotify, Tableau, and those tools don't really understand RDF. It's not compatible to the graph. As a result, the pharma companies have to find new tools. And data scientists have trouble to use the created files. We heard that use cases that scientists ask for are often too simple for the graph, meaning it doesn't need a graph. So we were asked to maybe propose more sophisticated use cases or wait for more sophisticated use cases. And also, we also heard from the foundation that, hey, let's develop the graph, maybe a little bit too complicated. Let's develop higher level API to simplify that. So this slide, we want to capture our experience since the last meeting. But at the same time, we were worried. Are we this guy at the lower level here that we gave up too early, right? It's challenging, it's difficult. I mean, people need to let's all do this together. But are we just feeling? Are we letting the frustration kind of take over the conviction or the vision, right? And this diagram, if you search in Google, you just search "do not give up." you find this diagram, you find this cartoon image. But at the same time, because of we also think about could the scenario be this diagram, that we make a lot of effort, but maybe it's time to really think about the complexity. Do we really want to go through all the trouble and then realize it may not be that user-friendly? Again, user-friendly is a subjective term. So again, this presentation, we're sharing our opinion and our experience. So we have this struggle. You can see that those two diagrams, if you search in Google for an image called "you should give up," you find the second image. So again, this is getting a little philosophical. All right, so we were stuck in this philosophical and kind of binary choice. Should we keep moving ahead? Should we turn around? Should we find other alternatives? But then we realized that we were wrong. We were wrong because we asked the wrong question, right? Instead, we should, instead of picking one, think that there's a shot for a goal at the very end of the tunnel. Instead, we should work on creating and illustrating, as a company, incremental value along the journey while we march towards that end, whatever that end means, right? We don't know if that's something is good or bad. We don't know. And we should, as a company, we should and have to deliver incremental value. Every hour that we ask the scientists and the data scientists join the meetings about data standardization, about data modeling, we should be aware that they are making the investment, and we have to try very hard to deliver incremental value. So this is kind of the cartoon that we made. This guy on the top, while he's digging this tunnel or whatever, he needs, or he should be entitled to discover incremental value, like one diamond, another diamond, and a bucket of them, right? And that should be, that is healthy, and that's constructive, and that's sustainable. So we started to ask the following questions. How can we, TetraScience, provide value to the scientists and data scientists on the order of months and quarters, like 1 month, 2 months, 4 months, kind of that's 5 months. That's it. This time range, this time window. How can we make sure that scientists, data scientists do not have to learn new tools, right? The learning curve will never be easy. How can we allow the pharma companies to use the tools and the technology they already invested in? How do we enable the informatics vendors, all the vendors, to consume and to produce ADF files? We also asked the question, how do we leverage HDF5? Because as we mentioned earlier, the technology is built on top of HDF5 and the tooling, right? That's a mature and popular framework. It has HSDS, HEDA, not H5 pi. Sorry about the typo. And we asked the question that we came to the conclusion or conviction that we need to focus on simplification and making it open, right? Just making it easy. That gave us the ability to automate. That introduces the possibility of scale, meaning that you can potentially produce more ADF files, more whatever this is, and the potential for real momentum and adoption, which then will lead organically to more user stories and justified complexity, which will kick off the next iteration of improvements, right? So you notice that I have an underscore here at potential momentum, because everything here we're talking about is the future, the vision. We don't really know what's the end of the tunnel. So there's no reason to introduce complexity before it is needed. So far, this is our kind of fundamental conviction and belief in our approach. So that philosophy or that realization motivated the TetraScience team to design the file converter in the following ways. So we first look at the data sources. Those are instruments, and you also have CROs, CDMOs that are producing the data. And then in the end, you have the ADF, right? We are dividing that in a two-step process. First, we want to convert data into an intermediate data schema file based on JSON. The reason we want to do that is that a lot of the informatics, particular informatics and data science tools, can consume JSON, can consume the flattened JSON or the tabular data. And then step two, convert into ADF and leverage Sparkle query and also the new toolings and use cases when they come, and when they are needed, right? So this is a two-step process. We then start to look at the graph that we produced ourselves. We divided everything into two segments. One is this orange one that captured a lot of the actual data. For example, experiment name is my test, sample batch barcode is XYZ, injection volume is 1 microliter, cell viability, I mean, this is a super crazy percentage, not going to be that high, but 60.5%, right? Those are the data. Then the graph also captures a lot of the philosophical metadata or relationships, like material A has the role of experiment sample is realized in an HPLC injection. So all those are triples in this graph, right? What is up here are usually the leaves at the very edge of the graph. What is in the blue is usually the relationships. You see there's a lot of lines connecting them, right? And we look at, okay, for the orange part, the data part, they are the most relevant to the scientists, data scientists, and software developers. For the blue part, they are mostly relevant to the semantic engineers and ontologists. Scientists honestly don't care about the blue part based on our observation. So we think about how can we decouple that, right? So leaf node provides the ability to capture whatever is on the edge or the leaves of this tree or graph. It captures the actual data, which is tailored to the scientists, data scientists, software developers. And then you have the ontology, right, that are designed by the semantic engineers, ontologists, which captures the relationships. And those ontologies should be captured in the Allotrope Foundation ontology, BFO, and any other ontologies that your organization wants to develop. So if we are able to decouple the semantic relationships from the actual leaves, but leave a hook here that they can be connected, right? It's not that they are totally separated, they're just decoupled. Then we can potentially allow the scientists and data scientists, software developers to focus on the data and data itself and deal with what they're comfortable with, and also leverage the semantic engineers in what they are doing, that they are good at. Another design goal we have is make sure that people can use Python to explore their ADF files. So this is something that they can plot a chromatogram Here they can look at the distribution of cell sizes in terms of pixels, looking at the data in the data package. So we want the data scientists to be able to just open up an ADF file and explore. They're able to write in the same language they are used to, use the same libraries they are used to, and explore the data from the experiments. We also want to make sure that currently some of the data scientists are stuck because they're not able to understand the data cube, right? Those are UUIDs. I mean, a lot of you know for a 3D chromatogram, you know what is the measure, what is the scale, right? I mean, you know that. But data scientists, a lot of people don't. They don't know how to understand this UUID because all the metadata about this UUID is saved in RDF. And in order to know RDF, get the data out, you need to Sparkle, and which, as I mentioned, based on our observation, is not the skill set that data scientists and scientists have. And it's not a skill set that is on the top of the list of things they want to learn or they have time for. So our approach is to make sure that there are human readable names on the data cubes. And also we introduce the unit, which means the data scientists can just read this using Python, Jupyter Notebook, and also you can use HDF5 groups Kita to run distributed query on the HDF5 files without knowing Sparkle and RDF. Right? This is the key. It's not that information was lost in the original implementation of proposed by the in the original implementation. It just they have to load the data scientists and scientists have to know semantic, web, and RDF and Sparkle. We also reviewed whatever is in the data description section. This is what's created, which means the ADF file can only be created and read by the ADF by the Foundation's Java and .NET library, right? I mean, index, GOSP, quads. I mean, you don't. I mean, you have to use the library to get information out. We kind of asked the question: if something can only be read and created and read by this library, then why is it different from any vendor proprietary file formats? I mean, structurally speaking, it has the same nature. So our decision, our approach is to make sure the same information that was in, I'm not sure if the term I'm using is correctly, but somehow put into this data description section can be available as just as simple files in the data package. You have the data description, the turtle file, and also the IDS JSON file, which means you're able to read the ADF file or consume it by non-allotrope libraries such as Python, R, Perl, or any other library that is compatible with HDF5. Here I want to bring up a concept that we heard from Boehringer Ingelheim, that the principle of orthogonality, to provide the best chances to have uninterrupted access to your data over long term, you should have at least two orthogonal, meaning vendor-independent ways to read all of the content. Meaning, whoever that produces the data needs to make it possible for the consumer of the data to read the file without using the producer's library. Otherwise, you have to. Otherwise, it's like the vendor proprietary files that the Foundation was created to reduce. Another design goal is to make it sure it's web API driven, right? We talk about simplification leads to automation, and then using the web API, you're able to ingest files and programmatically convert it. And combined with the TetraScience platform, you're able to convert it from end to end, from the raw data to the IDS and then to the ADF files. As a recap, here are the summary of the key features. That you have files. It's a two-step process. It should be designed for data science and cloud use cases. It's web API driven, that you can not only trigger the conversion programmatically, but also you can search the files produced using API. And lastly, by combining with the TetraScience platform, you're able to convert it from the vendor format directly to the ADF. And there's the traceability, the logging and other dedicated instance for single tenant deployment. Let me dive a little bit more into the details and how this works. So on the left side, this is the basic structure of the intermediate data file. Again, it is based on JSON, which is the most common data exchange format that all the website uses to talk to each other. The file converter will convert the metadata and summary data into the RDF graph following the modeling working group using the leaf node approach, not the full graph approach, and put that into the data description section and also data package. Right? The reason we put it into the data package is for the principle of orthogonality. This way, you can use any other library to consume the data, such that you don't have to worry about if the library was not maintained or supported 10 years later, you're not worried about losing access to the data. Data cube goes to data cube, but at the same time, having the human readable name and unit here. And then we have some large data, and we also put that into the data package. So overall, that's my presentation. And in this last slide, I just want to re-highlight what TetraScience encouraged the community to ask. Ask the question, how do we provide value to the scientists and data scientists on the order of month to quarters? How do we leverage whatever HDF5 Foundation has produced and developed, has been battle tested? And then how do we follow this natural progression and starting from simplification, automation to scale, demonstrate momentum, define new user stories, more sophisticated use cases, which justifies more investment, and start and iterate from here. So that's my presentation, and thank you everyone for your time.
Thanks, Ben. We have one question right now from John Hollerton. I'll unmute him for a second as I find his name in the list. There we go. All right, John, you should be unmuted.
Okay, thanks. Can you hear me?
Yep.
Yes.
Excellent. Okay, thanks, Ben. There's a lot that I agree with on this. There's a few things I take issue with, though. So the first thing is equating the allotrope libraries to, or the allotrope format to being a commercial tied-in format. I don't think that's strictly speaking true, in that it will be available to all allotrope members. And the second thing is, how do you read HDF5 without the HDF libraries?
Okay, so John, can you talk about your first point? Can you clarify that?
So unlike a commercial vendor's software, we don't normally have any tools to be able to access that data. It's in a hidden proprietary format, which we would have to then reverse engineer to try and work out how to get to it. Allotrope is very different in it's a published resource. So that I don't think that's a true equivalence. Okay,
let's focus on that, right? I'm not talking about the commercial aspect, even though right now people outside the foundation don't have access to the file. But I mean, let's not get into that. What I'm talking about is from a technology perspective. You need to use a particular library to create a file, and the only way you read the file is by using the same library, right? So this is almost like when we work with Thermal Excalibur file. We don't know how it is produced. It has to be produced by Thermal, but we can only read it via the Thermal library. It's the same with Waters mass links. So from that perspective, I can that's the equivalent. That's the similarity. You can say, I mean, it doesn't matter who produces that library. It's this time it's the foundation. The other case is the Thermal filter, but it's one entity that produces that, right? And that is not open source. I mean, the Thermal one is kind of I mean, at least the Allotrope one is not open to everyone. I mean, even if it is open, that's not the point. My point is that you need to use one library to create and the same library to read.
Yes. What about HDF5 then?
Yeah, HDF5. So okay, can you ask the second question again?
Yeah. So how do you read HDF5 data without the HDF libraries?
We cannot. We have to use the HDF. We have to use the H5 library.
Yes. So it's the same thing effectively.
No, HDF. There are several major differences. One is by allowing the file to be read by HDF5 library, Allotrope Foundation automatically, instantaneously made the file format much more popular and accessible. You are leveraging the community, the tooling, the experience, the debugging, the forum, everything built by that foundation throughout the years, right? So that's one. The other one is, as far as I can tell, nobody needs to pay membership fee for the HDF5 library, right? So that's another one. And another point I'm trying to make is not that the H5 library is fundamentally different, a fundamentally different library. It is still a library, right? It's still a library. What I'm talking about is it introduces one more orthogonal mechanisms to consume the data, meaning that you do not have to use, for example, you don't have to use the ADF Java C# library to read and write and read. Now you have another alternative, which makes the file format much more robust in the sense that more possibilities of consumption. For example, I give you
so Spin, just to build on this a little bit and maybe actually bring things, we're kind of getting close on time, but you know, there was an interesting point that came up in Heiko's demo when he was illustrating reading an ADF file written from OpenLab within the viewer, and you know, put out there that if other files are written that conform to the standard, then they can be read into that viewer as well. So the notion of this consistency and interoperability is a really important component of, you know, the strategy of developing the ADF libraries.
Yeah, but that viewer is also that viewer is still the Allotrope viewer. That viewer uses the Allotrope library. Right now,
yeah, just a second, Spin. If I can just finish. When we initiated this, you know, we did a pretty deep analysis of existing technologies and no longer existing technologies and other standards and approaches. And there is examples, and some fairly well known, of file formats that, you know, without being tied to a particular set of libraries, that is to say a specification interpreted by other multiple developers, of generating file formats that in name were named the same, but in fact were not interoperable. So that one written by one application can be read by another one that's supposed to be able to read that file format. John himself has sort of, you know, spoken to some of his experience about that. And so that was a very important part of the libraries. And there's added capabilities to the file that are important for other business requirements that were, you know, in the general scope that may not be actually part of the sort of, you know, simpler use cases, but certainly are important to other use cases that the standard is intended and the framework is intended to serve. And those added those other capabilities to the HDF5 file then require some additional capabilities at the API level to, again, make sure that those are implemented in a fully unambiguous and equivalent way. And then importantly, that includes the data model. So, you know, if we just have raw data and the same words, but in different data structures, ultimately expressed in different forms or in different syntaxes, if they're not equivalent, then ultimately that data is not interoperable, such that you could overlay two chromatograms on one another. So
I don't think we're talking about the same topic here. I'm talking about very incremental improvements to the foundation's traditional way of implementing things, such that it makes it more open. I'm not talking about
this will be a great conversation to continue to have, and thanks for, you know, recognizing the, you know, the accomplishments of the first high-level API, which is, you know, already showing some dividends. And so clearly it's, you know, a key point of the strategy. Matthew touched on it a little bit, and in one of the webinars, forget whether it's next week or the following, and maybe actually when we close we can put up the coming week's agendas. we'll have a little more detail into the current progress and the plans for more high-level APIs, additional ways to essentially mask that complexity, from developers and allow people to move more quickly. So I think it will address a lot of this. Yeah.
Yeah, I mean, this is a rare opportunity for us to at least share something that high-level API. We have concern for putting effort for the foundation to put effort into that, because if we have to create the complexity and then hide it, again, I'm just going to leave it here. We should think whether we should go after that complexity in the first place, because stopping at a simpler stage or level does not preclude anybody from going into the complexity, right?
Yeah, you're right, and that's absolutely what's fed the development and of the tabular model approach, and resulted in cranking out a good 10 models so far on that, right? Realizing that there is an approach where you could start there and then enhance it, and again, down to the use case, it just kind of depends on the level of detail you need. I'll just close with the fact that it was enlightening to me when we got into this, not being an analytical chemist necessarily by training, to learn that, the applications that run the instruments and capture the data from the instruments that are part of the conversation here generally have a relational database underneath the application. Now, why is that? Because it's complicated and there's a lot of things to keep track of and a lot of relationships. And so, in increments, complexity sort of fit for purpose, perhaps, but then, sort of masking that is definitely part of the strategy.
Yeah, complexity has to be justified. And we would advocate for the foundation to provide strong and very solid and crisp justification on the extra benefits provided by that complexity of full graph.
Right. And
so in the context of no alternatives, we have to compare that against alternatives. And yeah.
Okay, so we're going to have to wrap up now. Thanks again, Spin, for that. Good progress there, and good to continue to have healthy discussions within the community about implementation approaches, while we also try to adhere to an approach for standardization.